Hello everyone, welcome back to LeoAxis Tech. I hope everyone is doing good. Thanks for watching our part 1 and part 2 of the DNS series. Today we're going to conclude our DNS series with this part 3. I hope you enjoyed the 2 parts. And before I'm going to start this part 3, sorry for the mistakes which I have done in the part 1 and part 2. Mistakes might be from audio or video or the quality. But we'll make sure that our upcoming videos with high quality in both tech and non-tech. Thank you all. So let's begin this part 3 of DNS series. So here, first, we'll take a couple of minutes to revise the part 1 and part 2. Then after, I'll tell you the difference between the nslookup versus ping. Fine. So after that, we will see the top 3 best practices of DNS and how to overcome them. After that, we'll try to see the behavioral questions. Let's say if you are going for any interview and if you face any questions, behavioral questions, I'll tell you what is the behavioral questions as well. And if you face any behavioral questions, right, and how to tackle them with the STAR methodology. So we'll try to see these best practices today. So with this, we may conclude our DNS series. Fine. So let's start with the revision before we go into start this part 3. So as you know, we started our part 1 to cover all the foundations, right? We're done with the foundations in our part 1. So what are the foundations that we covered in the part 1? Like we discussed about the client and server architecture and the relationship. Then after we covered the IP address, protocol, port number, right? So along with this, I told you what is the importance of this DNS. And I also explained what is a ping. So here, I cover these topics with a simple story. Story like if you observe this client server architecture, I told you a hotel story, right? Saying that if this is you, if you approach a hotel, you are initiating a request. You are asking for a food. And the hotel on the other side, they are responding to you, right? They are responding to you. In between you, there's a waiter who is helping us to handle this request and to respond back. So here, in the same way, I connected this story to the technical side. In the technical side, let's say if this is you are using any device like mobile phone or laptop or the internet in order to access another computer, right? In order to access another computer where the website is running, right? Where our website is running. So in this case, the device or the software which is initiating a request or which is asking for the data is known as a client. And the device which is responding to other computers, right? It is known as a server. So here it means just like the hotel, which is responding to many customers at once. And it is open 24/7. And it has a higher capacity. Fine. In the same way, the server, these computers, even they are the capable enough to respond to many clients or many devices at once. Okay. So even it has to run 24/7. It has to be available 24/7 over the internet. So then only it can capable enough to handle many requests at once. Now, let me take you more deep. If you want to maintain these servers, we are using the data centers. We are using the data centers to maintain these servers. So data centers are the physical buildings where the servers are maintained. Okay. So the servers are maintained in these data centers with continuous power supply, with continuous cooling system, with high network, and with security features, etc. So if you observe here, for small companies or startups to maintain their own data centers and to manage these servers, it is very costly. So the solution is that to overcome this budget or responsibilities, you can go for the rental options from cloud computing service providers like AWS, Azure, GCP, etc. So you can get these IT services, you can set up your servers, you can spin your resources within seconds by using the rental services provided by these cloud computing service providers. We're going to cover this topic in the upcoming series. Fine. Now, coming to this IP address, protocol, and port number. Here as well, I covered a small story. Let me revisit that once again. In order to understand this IP address, protocol, and port number, I told one story saying that this is me. I'm in Hyderabad, and this is my address. And there is a friend of mine who is staying in Delhi, and it is his apartment address. And his apartment, he is staying in the particular flat. Okay, let's say the flat number is 102. Right? So this is my friend who is staying in this particular apartment address in the respective flat. Now, if you want to communicate with my friend, if I want to talk to my friend over letter, if I want to send a letter to my friend, here I need to follow three important things. First thing, the apartment address. This apartment address is not enough. I need to also mention the flat number. Only apartment address and flat is enough? No. I also need to follow certain standards, because if I'm talking in a manner, I need to follow certain grammar, certain communication, right? Certain protocol, certain rules, where my friend can understand my language. So it means I need to follow certain standards in my letter. If I'm talking to my friend, if I'm talking to my friend's father, I need to follow certain standards in my language, right? They are the three important things that I need to follow. In the same way, whenever we are talking to any server, now we know what we mean by server. It is a computer which is running the websites or applications or databases, right? 24/7, which is available to the other devices or the internet, responding to the other devices or serving to the other devices. Now, if anyone wants to talk to this server, so even they need to follow these three important things in the request. As I told you, these clients, we are initiating the request. So in our request, we need to follow these three things. What are the three things? One is IP address, one is a protocol, and one is a port number. We need to make sure that these three things are available inside our request. So then only our request or the internet will go to this respective server, and it will communicate to the respective service. Now here, if you see this IP address, for every device which is connected over the internet, for every device which is connected over the internet, they're identified with a unique address known as IP address. It is a IP address, it is a unique address to identify the devices over this digitally or over the internet. Just like our mobile cell phone numbers. Even our mobile phone, we have the unique cell phone numbers. Even for the mobile phone, we have the unique IMEI number to identify the device. Right? And just like our vehicle numbers, there's a uniqueness to identify the particular device. In the same way, to identify these devices which are connected over the internet, these devices are communicated by using this unique address, which is known as IP address. Right? So the server also having the IP address. Right? Now inside this server, just like this apartment, there are many flats are available. Okay. Just like this, inside the server as well, there are many services are running in the background. Inside the server, there are many services are running in the background. Might be SSH service, might be database service, might be web application service, might be application server. Right? So many services are running in the server. Now, how to identify these services? Right? Because in this server, there are many services are running. Right? Many services or many programs are running in the background. Now, to which exactly or how exactly we need to identify them? All these programs which are running in the background. So for that purpose, we are using something called port numbers, a logical numbers to identify these services, right? So this globally, we have the 65,000 plus port numbers that are available in order to assign to these services. Okay. For example, for the websites, okay, for the websites, the services for the websites are running at the port number 80 or port number 443. So there are two port numbers which are identifying or which are defining for the web server softwares. For the database server softwares which are running in the background, we are using 3306 as per the respective software, other respective service. Now, if you observe, as I told you, so we need to use this IP address. Okay, how the IP address looks like, it is just like a 10-digit mobile number. For the server IP address also, there are two versions. One is IP version 4 or IP version 6. If you see this IP version 4, how this format looks like, it looks like in this format, A.B.C.D. What in by ABCD, they are the numbers from 0 to 255. It means like 152.10.0.16. It is one number. It is example of server IP address. So don't worry about this, how exactly it define and all. In the upcoming lectures, I'll try to take one more series on the networking. It means we need to remember this IP address if you want to talk to this server where the website is running. Now, if you want to talk to this server about the particular service where the website is running, you need to use this protocol. Sorry, you need to use this port number 80 or port number 443. If you want to access if you want to talk to this respect to service. So that is the reason I told you we need to use this IP address in our request followed by the port number if you want to talk to the respect to service. Now, if you're talking to the respect to service, we need to follow certain language where the service can understand, right? Where the service can understand. That is what the protocol. So what in my protocol? It is a predefined rules and regulations. If you're talking to a particular port number where the service is running. So if you see example, let's say this is me now. If I conclude these things, if this is me, I'm in front of the laptop and I want to connect to a computer where the LeoAxis website is running. Okay, I want to connect to a server where the LeoAxis website is running. Now, for the internet, I'm initiating a request for the internet. So in my request, I need to make sure there is IP address, port number, and protocol. But if you observe, whenever I open the web browser, I simply type a name, right? I simply type a LeoAxis, like www.leoaxis.com, right? So our request is initiated. If I type this name, our request is initiated over the internet. The internet is taking our request to the server, and we are getting the response back with the LeoAxis website page. But if you observe, do the request really contain these three things? Yes, it contains these three things. How? Let me show you. Like https colon www.leoaxis.com. This is what we are searching. Right? This is how this URL looks like in the browser. Let me show you. So if I'm searching for LeoAxis website, simply I'll give, right? Simply I'll type for www.leoaxis.com. Right? That's it. Your website is loaded. Right? So our request for the internet. Now we are the client. Now it is a client software. We just typing this name called www.leoaxis.com. Our request for the internet, it reached to the server where the LeoAxis website is running. And we got the response in this format. Right? We got this response from the server. But if you see this, okay, if you observe this URL, so this is the URL how it looks like, right? Now, whether it contains the IP address, port number, and protocol, as I told you, the request for the internet, if it reaches to the server, if it has to reach to the server, we need to make sure our request contains IP address and the particular server number to which server you're going to access and the standards and the protocol. Right? There are the three things that we need to follow. But if you see this URL, whether it contains all these three details, yes, it contains. Let me decode this. Now, if you see this HTTPS, it is a protocol, it is a standards that we are using. When we are using these standards, if you are talking to a service which is running at the port number 443, if you are talking to a service at the port number 443, by default, we are using this protocol or the standards. If you're talking to the port number 80, it means we are using a protocol. By default, we are using a protocol called HTTP. Fine. That is one thing. So it means HTTPS means we need to understand that we are talking to a service called 443. We are talking to a service which is running at the port number 443 using this protocol HTTPS. Fine. So two things are fine. Now, where is the IP address? Yes, we are not using the IP address, but we are using the instead of using the IP address, we are using the domain name. Why it is like this? Simple. Because in your mobile phone, is it possible to you to remember all the phone numbers? No, right? Obviously, it is not possible to us to remember all the phone numbers. If you're calling to any friend, will you type a number or else will you simply type a name? What we'll do? We don't type a number. We'll simply use the names, right? Because it is not easy to us to remember all the cell phone numbers, which are unique. In the same way here also, it is not possible to us to remember all the server locations or IP addresses, which is very tough to us to remember. So to overcome that, simply we are using the names, just like the mobile phone. We are using the simple names. And the mobile phone, it is using a service. In the background, it is using a system, other service, to check the name respect to number, right? Because it is using the phone book service in our mobile phone to check what the name exactly representing. And it will get that number, right? It will try to get that cell number. Now using that cell number, it will make a call. It will initiate a call to the respective person. The same way, we are using the domain names. They're the fancy names, which is known as domain names, right? Now, will the internet can able to understand? Will the internet can able to understand this domain name? No. You are using a proper protocol and port number, but will the internet can able to understand this domain name? No. The internet can only understand the IP address, other numbers. Now, how we are going to help this internet to get this respective IP address? That is where we are using something called DNS. Okay, that is where we are using something called DNS. And we cover this DNS topic in the part 2 in a simple story manner. First, our device, just like this mobile phone, which is talking to this phone book service to get the exact number with respect to this name. So in the same way, our device is connecting to this DNS, stands for domain name system, to get the respect to location of the server. So the DNS, this system is helping us to get the respect to location of the server, right? This is respect to location of the server, right? So once you get the respect to location of the server, again our device will initiate a request with the proper location of the server and with the respect to service with this respect to protocol. This is how the internet will take the details from us and it will send the request to the respective server and the server will respond back to us. The server will process the request and it will respond back to us with the respective details using the same internet. I hope it is clear. Now we'll continue the rest. So now in part 1, after DNS, we also discussed two important network diagnostic tools. So one is ping and one is traceroute or traceroute. Now let me revamp these two tools along with one more important diagnostic tool, which is known as nslookup. So overall, we're going to discuss ping, traceroute, or traceroute, and nslookup. So these three important diagnostic tools that's we're going to discuss once again. So let me tell you a simple story here. Let's say whenever you open your website and like let's say if you're opening a website leoaxis.com, if the website is not opening, let's say you are facing an issue if the website is not opening, or you might feel that it is loading very slow. You might feel that it is loading very slow. Then how to overcome this? What you need to check first? If the website is not at all opening, and if even though if the website is opening, it is opening very slowly. So to whom you going to blame, right? So before blaming someone, we first ask three simple questions. What are the three simple questions? First one, is the website name, is this domain name, the domain name that which you are used in order to access their website, is the name is correct or not? That is the first question you need to ask by yourself. And the second question, can I reach the server where the website is loading? Because this LeoAxis website is running in a server and you are trying to connect to this server to access this website, right? So first, if you confirm that, yes, the name is proper, it is representing this server IP address. If it is confirmed, next thing you need to confirm that whether the server is reachable or not. Okay, whether the server is reachable or not. That is the second question you need to confirm. So third one, what path is my request is taking? You need to also confirm the path of your request. So what path is my request taking? You need to also check the path that is initiated from your device to the server where the website is running, right? So overall, you need to confirm that the domain name that which you have used, is it proper or not? That is the first thing. And the second thing is the server is reachable over the internet. And the third thing, what is the request path that had taken place from your request to server? So there are three things that you need to confirm in order to troubleshoot these things. Okay. So let me tell you one by one. So here, to answer these three basic questions now, we are using three basic tools. So these three basic tools are, one is nslookup, and one is ping, and one is traceroute. We use traceroute for Mac or Linux, and we use tracesec for Windows. So the other three important network diagnostic tools, which are the CLI tools, command line tools. They are the programs. You can also call this utilities. The CLI utilities are the CLI programs. They're the softwares. They're the programs which are inbuilt in any device. So which is helping us to diagnose the network related issues. Even these three programs, which are inbuilt in your operating system, even they are taking the support or help from the DNS, domain name system. Right? Whenever you are using this tool, whenever you are applying this tool or calling this program is taking a support from the DNS in the background to give the response, to give the proper answers to you. Right? So this DNS in detail we are covered in the part 2. Again, I'll try to revisit these things. I'll explain you in simple as a revision. So let me see one by one. What is the nslookup, ping, and traceroute or traceroute? First, we'll start with the nslookup. Example, how to use this nslookup and how it is helping us. If you see nslookup, let's say example, if I'm using like nslookup, you can use small. So if you use like nslookup, you're using this program, you are using this utility followed by the domain name like google.com. So if I'm using nslookup google.com or nslookup leoaxis.com or facebook.com, what this nslookup is saying that it returns whenever you are initiating this request, whenever you are calling nslookup to find this domain name. Immediately, this nslookup is taking support from the DNS and returning an IP address. Okay, it is responding or it returns an IP address. If it is returning an IP address, it means the DNS is working fine. It means the domain name is proper. The name that which you are used is existed. It exists and it is pointing to the respective IP address. So with this, we need to confirm that yes, the name which I had used, it is proper. It is correct. And it is also mapping to an IP address. So that IP address will get the response as an IP address. So by this, we need to confirm that yes, the domain name is existed, right? It is pointing to the respective IP address. And the DNS is also responding correctly. I hope it is clear. Right? Let me show you. Suppose if it does not return an IP address, if you're not getting an IP address in the response, it means the problem is DNS. Okay, it means the problem is with this DNS, which is not responding to you. Let me show you how to overcome this. Let me show you in practical. Let's say I'm in the command prompt. I'm using my Windows laptop. I'm in the command prompt. This is a CLI tool. Okay. So now, if you see this, we have used the nslookup followed by domain name leoaxis.com. So now this nslookup is used to check the DNS resolution. So what it is answering? It is answering that is the domain name resolving or not. It means whenever we type any domain name, is the name is properly mapped to any IP address or not. So with this, we need to confirm that is the name is existed or not. Right? If it is existed, if the name is correct, which IP address DNS is giving for this respect to domain name. Right? It means even this nslookup, it is taking the support from the DNS, domain name system in the background, right? Which we covered in the part 2. So the DNS is taking this name, it is giving the respective IP address. Fine. So this is how this nslookup is helping us. So if you see this, so we got the answer from the non-authoritative, it means not directly from the real owner or real server of the leoaxis.com. We got the cage server in between. We are the cage servers. So we got the answer from the cage server. That is what the non-authoritative. And this is a respective address like 185.38.109.202. It is a respective cage addresses. It is like a parking address. So with this, we need to confirm that yes, leoaxis.com, this name is existed and the DNS system is properly resolving this to give the respective IP address. I hope it is clear. As already told you in the part 1, okay. Using the nslookup, it's confirmed that the domain name is existed and it is pointing to the respective IP address and the DNS is also working, right? So it is checking the name part. So it is checking the name part. Yes, the name is valid. Next thing we need to confirm that whether the server is reachable or not over the internet. For this purpose, we are using the utility or the program called ping, right? Okay. So this is what it is saying. So how this ping is used? Ping is like saying, if you are using the ping or if you are using this ping program, it is like calling this server. Okay, it is like calling this server. Example, let's say if I'm using ping google.com or ping leoaxis.com. So using nslookup, confirm that yes, these domain names are valid and it is pointing to the respective IP address. Now to confirm whether the server is running and whether it is available over the internet or not, we are using the ping. If you are, let's say if I'm calling ping leoaxis.com, then what this ping is saying that the ping, it is taking support from the DNS and knowing the IP address, right? It is taking support from the DNS and getting the proper IP address of this server. It is calling this server, saying that hello server, are you there? Right? It is just making a call, just like a missed call. Okay, that is calling a server saying that hello server, are you available? Are you there? And if the server replies that yes, it is just saying like hello, calling like hello. It is saying that yes, yes, I am here. Okay, so in this case, we need to understand that yes, this server is reachable. Okay, this server is reachable. So using this ping, how it is going to help us now? Using this ping, it is helping us to confirm whether the server is reachable or not over the internet. First thing, it is confirming that whether the server is reachable or not. If it is reachable over the internet, how fast the response? It is also calculating the response time, how fast the response you are getting. Let's say I said hello. I say hello to the server. And how fast I'm getting the response from the server. If it is reachable, how fast it is responding to me once I make a call like hello, and what is the response time it had taken. That is what this ping is helping us, right? So let me show you how these things are working in the practical. Let me explain you this. Right? Now we'll see this ping. If you use a ping followed by leoaxis.com. So now it is sending, like now it is saying a hi to the leoaxis.com server. Right? Now it is sending a small message. Okay, small packets of data to the LeoAxis server. Now we are also getting the response, the same response. Right? We are also getting the response. Okay, if you see this time, what is the maximum time? It is just like 251 milliseconds. By seeing this, we need to understand that yes, so we are successfully able to reach this leoaxis.com. It means this server where the leoaxis.com website is running, it is reachable and is at so and so time, right? It is a response time that we had received, right, in milliseconds. So this is what we need to understand. With the using of ping, we can confirm that whether the server is reachable, and if it is reachable, what is the response time that we are getting. I hope it is clear. Now, using the nslookup, we confirm the domain name is correct, the DNS is working, right? And you are getting the IP address. Okay. Now, using the ping, we had confirmed that yes, the server is reachable over the internet and it is also responding in so and so time. After that, we also are using one more important tool, which is known as traceroute or traceset. Let me tell you what is the importance of the traceroute and traceset once again. You see, by nslookup, we confirm the name, we got the answer for the name, and by using the ping, we got the answer for the reach, whether the service is reachable or not. And to define the path of your request, which is going to the server, we are using an important tool known as traceroute or traceset. So this is the tool, but the naming is different here. Traceset, we use the traceset naming for the Windows operating system. For the Mac and the Linux, we use the traceroute. So what is the purpose of this traceset or traceroute? If you are using the traceroute or traceset, as I'm using the Windows, so that's the reason I'm using the traceset. So if I'm using the traceset in my system, right, it is actually checking the path of your request. Okay, so by seeing this, we need to confirm where is the delay is happening. Okay, where is the delay is happening? Because let's say this is me and I'm searching for leoaxis.com. Okay, in my browser, I'm searching for www.leoaxis.com. Right, and it has to go to this server. It has to reach to this server. It is our end location. Fine. Now, whenever we initiate a request, it does not go directly to this server. It passes through many routers. It passes through many networks. Right? It passes through many routers, R1, R2, R3. Each step, each router, our request is crossing each router. Okay, here each step is called as hop, HOP. It is like a stop. Okay, so to make it clear, let's say this is me. If I want to go to office, okay, right, I need to cross many stops. There is not a single stop. Okay, to reach the office, it is my last destination. Now to reach this destination from my point, I need to cross many points. Okay, point 1, stop 2, stop 3, right, stop 4. Likewise, in the same way, whenever we are initiating the request, it is crossing many routers in between. So that each point is known as hops. So by seeing this, we need to confirm that, okay, traceroute or traceset. How to use this traceroute? Like traceset followed by website name, leoaxis.com. Or traceset. If you're using Mac or Linux, you need to use traceroute followed by website name. So what it will return? It will return time taken at each step and the number of steps. Okay, time taken in each step and the number of steps. Let me show you this one by one. So I'm using traceset because I'm using the Windows OS. So that's the reason I'm using traceset tool or traceset program followed by website name like leoaxis.com. So each line representing one stop. Okay, each line representing one stop and the stop respect to router details. Okay, router IP address. Right now it is tracing routing to leoaxis.com to this IP address. Now to reach to this IP address, okay, maximum it can load 30 stops. Okay, 30 hops means 30 stops. Fine. So to reach this server, what are the stops? So first stop is our local system, local router in my network, and it is the second stop. Okay, to the IS, okay, internet service providers. The third stop, fourth stop. So likewise, it will give all the stops and what is the time taken and where is the time delay. So you can also see where is the time delay that is happening. Right. So each line shows that each router crossed and what is the time taken at each step. And by this, you can understand where the delay or break is happening. And here, each step is called a hop, HOP. Like where it is loading here. So this trace route or tracer, it shows the journey of our request from our system reaching to the server. So I hope it is clear. So using the nslookup, it will check the DNS or the name validity, and using the ping, it confirms whether the server is reachable on the internet. If it is reachable, what is the response time? And using the trace set, it is showing the request path, the complete request path reaching from your system to the server. I hope till here it is clear to everyone. Fine. Now let's move to the next step. So far, we're done with the revision of part 1. Now we'll move into the revision for the part 2 session. So in the part 2 session of this DNS series, domain name system, we had covered the core of the DNS. So we have seen how this DNS is working. So in order to cover this topic, I had used one story here. So in this revision, first I'll explain you the story, what we covered in the part 2 in brief. Then I'll try to cover the story to the technical aspect. So once we're done with this revision, along with this, I'll add a new topic, which is known as a security concerns. As a part of the part 3, I'm going to cover the security concerns once I'm done with this revision. So in the security concerns, I'm going to explain you top 3 DNS security practices with a real world involvement with clear technical terms and its cause and effective flow, right? So in order to understand these security concerns, first let me revisit this part 2, where we cover this DNS in a simple story manner and its technical aspects. Let's start. So I started this part 2 with a simple story using a college. Fine. So first I'll give the story using this college, then the same story will connect to the technical side. So this college story I had covered using the two conditions. One is a condition 1 and one is a condition 2. In the condition 1, let's say this is me. I went to a college as a fresher. Okay, now I need to know where is a CS lab. I need to know where is the main cafeteria. I need to know where is my friend Rahul hostel. I need to remember all these locations of this college, right? So in order to overcome this, because this college is very big, so I don't have any idea, right? I don't have any idea about these proper locations of this college. So in order to overcome this, the college had provided a printed book to me. They provided a printed book which contains all the locations of this college mapping. So it is mapping all the college to its proper locations, like saying that main cafeteria is in the B block ground floor. Okay, and CS lab, it is in the C block, second floor, room number 201. So like this printed book contains all the details of the college mapping. So this printed book is provided to each student of this college. Fine. But initially it was good, but slowly the chaos had started. Why? Because if the data is changing, if this mapping is changing, if the new data is coming, in the sense like new cafeteria had opened, okay, or the CS lab is completely changed to another block, or else new students had joined. What about this printed book? It will become outdated, right? It will become outdated, and we need to have a new printed book. It means we need to have the reprint. We need to go for a reprint every time. That we need to update it time to time if the things are changing. So, which is very lot of hectic process, right? And chaos had started. So this is the disadvantage because it is outdated every time if any things are changing. Fine. So to overcome this, the college had decided in the condition to overcome these disadvantages, right? The college had decided to set up a campus help desk system. They decided to start a campus help desk system. They started one help desk system to resolve this process. Now, if you want to know the CS lab location, okay, first what I'll do in this process, first I'll check my internal memory, right? First, directly instead of contacting this campus help desk system, first I'll check my internal memory where the data is stored, right? I'll check within my memory in my brain. I'll confirm, I will recollect whether I know the CS lab or not. If I'm not able to recollect, then immediately I'll ask my immediate neighbor, okay, like my roommate. So I'll ask my roommate, hey, my dear friend, do you know where is the CS lab location? Even if my roommate unable to recollect. So even if the roommate is unable to recollect, so what I'll do immediately, I'll try to contact this. Okay, even if the roommate is not able to recollect, then what I'll do immediately, I'll contact this campus help desk system. Right now, this campus help desk system, it is not a single person. It is a group of members who are helping us in order to resolve these locations. So let's say this campus help desk system contains 4 important persons. Okay, it's a team of 4 members. Like it's a person 1, person 2, person 3, and person 4. And each member having their own responsibilities. Each member having their own responsibilities in order to resolve these location details. Let's see how it is happening. So when I approach this campus LDS system, it means I'm calling this person 1, asking for where is the CS lab. Now this person 1, first, he will check his internal memory. Even this person having its own internal memory. This person will check its internal memory or internal data, whether he or she can remember the CS lab. If this person 1 unable to recollect or remember the CS lab, or if the person 1 he don't have or he or she don't have the CS lab details, right? Now this person 1 trying to contact to the person 2 immediately, right? Now this person 2 is saying that, my dear person 1, my dear friend, I don't have the CS lab location, but I know who is managing this lab details. Please kindly approach person 3 for lab details. So with this, what this person is doing, again is making a call to this lab. Okay, again is making a call to this person 3 and asking for CS lab details. Now this person 3 is saying that, thank you for approaching, right? First, let me check whether the CS lab details are available or not. This person 3 is confirming whether the CS lab details are available in his registry or not. Now he's checking the CS lab details. Okay, he's confirming that yes, CS lab details are registered, but the complete exact location is not available with us. Okay, it means the person C is saying that the CS lab is registered in our diary, but the exact location is not with us. For exact location, kindly approach the person 4 for exact location. So with this, again, this person 3, okay, with this person 1 is making a call to person 4, asking for the CS lab details. Now this person 4 is saying that yes, you had approached right. So we have the details. Okay, we have the details with us. Now this information of the CS lab, okay, information like CS lab, building of block B, in the block B, third floor, okay, room number 302. So this information which is stored with the person 4 is sharing to this campus LDAP system. Now taking this information, this campus LDAP system is informing to this respective person. Now using this location details, now this person might reach to the computer science lab. So this is how it is happening. You might feel very headache. Why this story? Very complex story. But this is how the DNS is also working. You want to see how? Let me take you to the technical aspect as well. Just like this story, which is helping these college students in order to get the exact location. The first condition is having the printed book, but because of the hectic process chaos, which is outdated every time, we are the condition 2. It's a smart solution to overcome this location process, to resolve this location process. Right? In the same way, if you take the story to the technical aspect, let's say this is me. I'm in front of my device. It might be laptop, desktop, or mobile phone. Whenever I'm trying to search for a website like LeoAxis.com, right? So my request is going to the internet. My request for the internet, right? I initiate a request for the internet. Now the internet has to take this request to the server where the website is running. Okay, to the computer where the website is running. In order to make this process, the internet requires the exact location of the server, right? Exact location of the server. But we are using the domain names. We are not using the IP address. We are in the domain names. It means will the internet able to understand these domain names? No, the internet, it won't understand the names. Now, how we are helping the internet with this exact location? Who is remembering, right? Who going to know about this exact location details? So that is where we are doing the DNS. But before DNS, just like this college, two conditions. Here also to help the internet to give the exact location, to help the internet with these exact locations. So what we are using here also, we are using two things. One is before DNS. One is after DNS. After DNS existed, how the DNS is helping us. First, we'll see before DNS. It means before DNS means, let's say there are many computers which are connected over the internet. Okay. Now let's say it is during 1970s, at the time of 1970s. If I want to access a website which is running in this computer, if I want to access a website like facebook.com, if I'm trying to access this website, okay, or the internet, which is running inside this computer, right? So in this case, how a request exactly reached to this computer? So during 1970s, we used to maintain a local file. Okay, we used to maintain a local text file within our computers. Every computer used to maintain this local text file. What is this text file contents? This text file contains all the website, okay, all the domain names with the respect to IP addresses. And this file is known as host.txt. So this is the file where all computers contains, right? This is the file, local file, which every computer contains in the local system. Now, whenever I am typing facebook.com, immediately our computer is contacting. Immediately our computer is searching for this name and its respect to IP address from this local file. And after knowing the IP address, with that IP address, it is initiating a request to this server. This is how happening in the before DNS, just like the college printed book, where it contains all the entries. But what is the chaos here? If the new entries comes, if the things are changing, the book will be outdated. Here also in the same way, the internet is very big. Millions of computers are adding to the internet every day. Right? It means it is our headache to update it manually. If the internet is growing, it is our headache to update it manually, which is highly impossible for the large network. Right? So in order to overcome this, and also there is a data inconsistency. Right? Data inconsistency means, let's say this is the IP address that is there in my local system. It is not, or it is not required that the other person is also maintaining the same IP address. So there might be data mismatch. Okay, data inconsistency. So this is a lot of chaos. So to overcome this, the DNS, the domain name system, came into the picture. To overcome this, the DNS, the domain name system, came into the picture in order to resolve these locations of the respective domain name. So it is now centralized system. It is a centralized system helping us to resolve these domain names. Right? It is as per the individual local system. Now to overcome that individual local system, it is a centralized mechanism, a centralized system which is helping us to resolve the domain names. Just like this campus help desk system, it's a team of 4 members which are helping us to resolve the domain names. So here also what happens here, if you want to access any website, let's say I'm in front of the system, if you want to access any website like LeoAxis.com. So in this process, first my system will check its browser memory. Okay, this browser memory, browse cache, which is known as cache. Cache means temporary memory. So whenever I'm typing leoaxis.com in my web browsers like Google Chrome, Microsoft Edge, the website itself, it will check its internal memory first, browse cache, checking whether I can remember this website location or not. Like just like our internal memory, just like in the above example, we are checking in our brain memory. So in the same way, whenever you're typing any website name, first it will check its browser memory. Okay, temporary memory, which is known as browser cache. If it is unable to recollect this IP address or the location of this leoaxis.com, okay, immediately it will move into this OS cache, your system OS cache, which is the local DNS. It is also known as local DNS cache, where it is checking with the host.txt files. Okay, still we are doing the host.txt files. You can find in your Windows, you can find in the system32. The system32, you can find this host.txt file. So our browser cache is checking with the OS cache. Okay, to find the location of this leoaxis.com. Even if the host.txt file, if it is unable to recollect or if the data is not found, immediately our system will make a call to DNS, which is known as a domain name system. Even this system is not a single person, it's not a single server, that is not a single machine. This system contains 4 important servers. 4 important servers which are helping to resolve this location with respect to domain name. And every server is having their own responsibilities and they're working in a hierarchical manner. Just like in the above story, like college example, that every person is working in a hierarchical manner. Okay, right? Like levels, everyone having their own responsibilities and they're working in the levels. In the same way, in this DNS system, where the 4 important servers are working in hierarchical manner and every server having their own responsibilities. Let's see how it is working and what are all the servers part of this DNS. So it means here we have the 4 important servers. The first server we are contacting is recursive resolver. Right? And then we have the root DNS server. And then we have the TLD servers. TLD stands for top level domain. Then we have the authoritative name servers. Authoritative name servers. So it means whenever our system, if it is unable to find out the location of the leoaxis.com, immediately it is asking in the background, immediately it is connecting to this DNS. In the DNS, first it is talking to the recursive resolver, a server maintained by the internet service providers, your internet service providers. Let's say if you're using Jio, Airtel, BSNL. So those internet service providers are maintaining these recursive resolvers, servers. Okay, even the Google, okay, Cloudflare. So they are the companies who are maintaining these recursive resolver servers. So what is the purpose of these recursive resolver servers? They are taking the request from the client in order to resolve this domain name. So it means from the client, in order to resolve this domain name, the request will come to this recursive resolver first. Okay, now we are asking the recursive resolver. Our computer is asking the recursive resolver, right? Where is the leoaxis.com? What is the location of the leoaxis.com? Okay, what is the IP address of the leoaxis.com? The recursive resolver, it will check its internal memory. Okay, cache data, right? It stores the data temporarily, so it is checking its internal memory first. If the data is not found, if the location details are not found, immediately it is asking the root DNS server, right? So root DNS server is saying that, yes, you are asking for leoaxis.com, but I don't have the exact location details of leoaxis.com, but I know who is maintaining this .com TLD. So this .com, right? .org, .in, .net, these are all known as TLD. TLD stands for top level domains. Top level domains. Now this root is saying that, root DNS server is saying that, I don't know the exact location of leoaxis.com, but I know who is maintaining this .com TLD. Kindly approach this .com TLD. Now immediately the recursive resolver will connect to this TLD server where it contains the .com details. Now it is asking, my dear .com TLD. Can you please tell me what is the LeoAxis.com details? Now this .com TLD, first it will check its registry, its database, whether the LeoAxis.com, whether the name is available or not in the database. First it will confirm whether the name is registered or not. If it is registered, it is saying that yes, the name is registered and this is the address and this is the location where you can find the LeoAxis.com details. Now this TL is saying that yes, this name is available. Go to this NS. NS stands for name server. Go to this NS server, name server, where you can find the location details. So now with that NS server details, we are making a call. Okay, this recursive resolver is connecting to the authoritative name servers. You can also call it as name servers or authoritative name servers. Right? Who are the authoritative name servers? Example like our GoDaddy. You can use a website like GoDaddy or Hostinger, Namecheap, Cloudflare. In the AWS, we have the Route 53. So they are the examples of the authoritative name servers. Now using these name server details, we are this recursive resolver making a call or connecting to this authoritative name server. Now this authoritative name server is saying that, okay, authoritative name server or the name server. It is saying that yes, we are the name server, okay, right, where we have the information, right, we have the information in the form of records. Now this recursive resolver is connecting to the name server. What in my name server? It is a container. It is a container, or you can also call it as hosted zone. You can also call it as a container or hosted zone to store the information. Okay, it is used to store the information. So we are storing this information in the form of records. So what in my records? It is the information that we are storing. It is like items or entries. And we are representing each entry as per the information. Example, we have the record type here. Okay, we are creating a record. We are using record type here. For what? To store the information of the domain name and its respect to IPv4 address. Or else we are using the record type quadrant A, 4S. When to use this quadrant A, 4S record type? If you want to store the information using the, okay, for your domain name to this respect to v6 address. So like this, we have the record types as per the information that which you're going to store. And these records are we are storing in this hosted zone or container. And these hosted zone container are represented with these name servers. These name server details are available in the TLD. That is what the TLD is helping us to approach these name servers. So now our recursive resolver is approaching these name servers where the information are available in the form of records. Now this recursive resolver is asking, please tell me LeoAxis.com details. So by seeing this, okay, by seeing this, now it will check the domain name. Achha, okay, where the record type A. Okay, where the domain name and where the record type A. It means it is mapped into this IP address location. Now immediately this data will be go to the recursive resolver. This data will be go to the recursive resolver with respect to IP address. Now this recursive resolver, again it will update us with this IP address. Okay, it is helping us with this location of the domain name. Now using the IP address, we are making a request for the internet. That's it. This is how it is helping us, right? This is how it is helping us in order to find this domain name and its respect to IP address. So every day, if you are accessing any website, Facebook, Amazon Prime, Twitter, every day we are using this in the background without knowing us. We are using this system every day. If you are accessing any website, it means by default you're in the DNS in the background. You might assign how much time it is taking. It will take hardly just like 5 to 10 milliseconds, less than that also. It is hardly taking just 5 to 10 milliseconds, less than that also sometimes. So fast it is working and helping you to resolve the respect to domain name IP address. Just like the simple, if you want to connect, just like the mobile phone, we don't remember all the contact numbers. As I already told you, we don't remember all the contact numbers. Here we are using a service called phone book service. Simply we use the names, fancy names, and mapping to the respective contact numbers. So whenever you type any name, our cell phone is contacting this phone book to find this respective number. So once the number, okay, once it came to know about the number, then it is making a call with that number to the respective person. In the same way, our device, whenever you're accessing any website, it is contacting the DNS, and the DNS is helping us with the respective IP address. Now taking the IP address, we are making a call to the server. It means the DNS is also acting like a phone book of this internet. It is a phone book of the internet, helping us to resolve the domain names and its respective locations, the respective IP addresses. So that is how the DNS is working, which we covered in the part 2. In the part 2, I also told you something called TTL, time till you. Okay, it is nothing but it is a caching, it is a timer that which we're going to set in an organization ABC, and we have the website which is running in the server. And this is the IP address of the server, and this is our website. And if any customers want to access this website, okay, you need to remember this IP address. But will it possible to you to remember the IP address? No. Even our business won't run, right? If customers are trying to access the website with this IP address, our business won't run. No customers will show interest to access this website, right? Will you remember, like, if you want to access this website, you need to remember this IP address, which is 190.12.16.0. Will it possible? No. Our business will lose. So what I need to do as working in this organization, first I'll purchase a domain name. To my website, I'll purchase a domain name to present this website. So where to purchase this domain name? Like GoDaddy, you can go to GoDaddy, Hostinger, okay, Route 53, like any domain name, like authoritative name servers. Okay, you can go and you can register, you can purchase or register the domain names for your website. You have to find the domain names, like facebook.com. Can you able to purchase that name? No, because already someone has registered that name. Just like the vehicle numbers, cell phone numbers. Even here also you need to purchase the names for your website. Okay, once you register, once you purchase, okay, automatically a name server, a container, a hosted zone will be created. Okay, with this name server details, a hosted zone will be created. Now, what I'm doing, I'm creating a record now. I'm creating a record. Now, if I want to map this domain name with IP address, what I'll do, I'll create a record IP, mapping this domain name and with this IP address. That's it. Now, my clients who want to access this website, which is running in this server, instead of using the IP address, they simply use this domain name. So they simply type the domain name in the browser. Okay, in the Microsoft Edge, Google Chrome, you simply type the domain name. So immediately, as I told you, it will check in your local system, this browser cache and your OS cache. If the data is not found, right, because the internet don't know, you initiate a request to access this website. Okay, you initiate a request to access this website. Let's say I purchase the domain name saiguda.info. This is my website name. Now you're searching in your browser saiguda.info to access this website, right? But this data, this IP address details is not available with us. Even the internet, they don't understand this name. So it means it requires some other help to find this respect to IP address details of the server. So now immediately it is asking the DNS. In the DNS, first it will ask the recursive resolver. The recursive resolver is searching for this domain name details. If the data is not found, it is asking the root. This recursive resolver is asking to the root, where is the saiguda.info details. Now this root is saying that I don't know where is saiguda.info, but I know where is this info details. Now using that location, using that information, this recursive resolver, it is making a call to this TLD, which contains all this .info details. Now again, this recursive resolver is checking this TLD, which contains all the .info details. Where is the saiguda.info location details or IP address? The TLD will confirm first whether the saiguda.info name is registered or not. In its database, it will check whether this name is available. If the name is available, what is the name server details? So these details are providing to the recursive resolver. Now using the name server details, our recursive resolver is making a call to the authoritative name servers, where we created a container or hosted zone with this name server details, where it contains the records, as I shown you, right? Just like this. So we went to GoDaddy or Hostinger. Okay, purchase the name, immediately a name server details are available with these records, right? So these details, these name server details are registered in the TLD, right? These name server details are registered in the TLD. So it is giving back to the recursive resolver. Whenever it is asking for the location details, this TLD is helping the recursive resolver with this name server details. Now using the name server details, right? Using the name server details, our recursive resolver, okay, it's making a call to the name server for this information. Now this name server, what are the information that is stored inside this name server in the form of records? So this information it is providing back to this recursive resolver. Now this recursive resolver, it is storing these details temporarily. Right? This information, it is storing these details temporarily. So how long it is going to store these details? As I told you, it is going to store these details temporarily in its cache memory. Right? But how long? So that is what we're going to define with the TTL, time to live. Right? TTL stands for time to live, which we covered in the part 2. Let's say given time to live like half an hour. Right? So this recursive resolver, instead of asking this DNS every time, again and again, if we, instead of asking the same DNS information every time, this recursive resolver can store this information till half an hour, and every half an hour it will get updated, right? So that is what this TTL is helping us. Now these details will be provided to the client whenever they are initiating a request from the recursive resolver, right? Now using that information, using the details of the respective website, we are again initiating a request or the internet. Now that internet will take our request and it will make us to reach to the server in order to access the particular service. Now the service will accept the request, it will process the request, and it will respond back to us. Right? This is what we have covered in the part 2. I hope it is clear to everyone. Now we'll try to understand 3 important security concerns with respect to this DNS. You might ask, Sai, is the DNS is not safe? Of course, it is safe, right? Most people secure their applications, and DNS is helping us to resolve this respect to IP addresses. But still, the attackers first attack the DNS. Because if DNS is controlled, everything is controlled. Fine. So what are the security concerns with respect to this DNS? Let's understand. The 3 important security concerns we're going to discuss now. One is spoofing. Right? Spoofing. Or you can also call it as DNS lie. Okay, DNS is lying to you. DNS lies. Second one is DDoS. Stands for distributed denial of service. It's a distributed denial of service. It is one more important security concerns with respect to this DNS. What do you mean by this? To make it clear, it means DNS is overloaded. With this attack, the DNS is overloaded. So with this spoofing attack, the DNS is lying to you. Okay. And what is the third one? Third one is the zone transfer. So what do you mean by this attack? So if any attacker using the zone transfer type of attack, it means the DNS is oversharing the details to them, to the attackers. So there are 3 important security concerns that we need to understand this DNS spoofing. Let me give you a simple story here. Let's say this is me. I'm in front of the laptop and I'm trying to access a Facebook website. Okay, I'm trying to log into the Facebook. Right now, I can see the Facebook login page. How it is working? First, the request will go to the DNS. The DNS is providing the IP address. Now, using the IP address, the request will go to the server, right? And the server is responding back to us. And where I can see the login page. And in the login page, I'm providing the username and password. Here, one thing we need to confirm whether the IP address provided by the DNS in order to access this Facebook server, is it a genuine server IP address or any fake server IP address, right? So that is what we need to confirm, because the attackers might sitting in between the DNS and they might providing the fake IP address to you. Okay, they might giving the fake IP address details to you for this respective website. So with that IP address, what is happening with the fake IP address? It means the login page which is loaded in your laptop, it is also a fake website then. Right? It might be a fake website login page, which is similar to the real Facebook website. So it means what are the username and password we have provided? It means we have provided these details, these credentials in the fake website login page, which is looking like Facebook. Who done these things? The attackers who is sitting in between this transition. They have done all these things. So it is DNS is lying to you. That is what I told you. This kind of attack is known as spoofing or DNS lies. So which is making us to land on the fake websites. And the attackers are stealing our credentials. What if you are using the e-commerce website? So with this kind of spoofing, the attackers might steal your credit card details or very sensitive information. So to overcome this, we have the solution here, which is known as DNSSEC. Stands for Domain Name System Security Extension. Okay, it is a domain name systems security extensions. So what it is doing, it is a digital signature on your records. It is a digital sign or a stamp. It's a digital stamp on your records. Okay. Now this DNS, what it will do whenever it is getting this IP address, IP details from the name servers. Okay, from the name servers, it will confirm whether this information is genuine or not. How? Because this NS, this name servers, is having a stamp with this DNSSEC. Okay. It means what are the information provided by the name servers? This DNS first confirm whether it is a genuine information or not by seeing this stamp. Then only after confirmation, these details, genuine details are provided to you. So that is how the DNSSEC is helping us with this digital signature. Fine. If you are getting the information without DNSSEC, it means the seal had broken. It is not a genuine details. Right? So that is how we need to understand. I hope it is clear to everyone. Fine. Now, what is the next one? Next one is the DDoS. DDoS attack. What in by DDoS attack? It is a distributed denial of service attack, which is also known as DNS overloaded. What in by DNS overloaded? So to make it clear, let's say, imagine there is a restaurant, right? There's a hotel with 20 tables and 2 waiters. Suddenly, 5,000 fake customers had entered this hotel. They are not ordering anything. They are ordering nothing. Okay, they keep calling the waiter. Right? So, but the real customers who are about to order, they can't get the services. Right? They are the real customers. They are the legitimate customers who are really waiting for the servers, who are really waiting for the orders. They're not getting the services because of this 5,000 fake customers who are unnecessarily wasting the time. Right? Now, the real customers are impacted because they're not getting the service on time. So they leave the hotel thinking that the hotel service is very bad. So this is what known as overloaded. This hotel is overloaded with the fake customers, right? Where they are not ordering anything and they are making the real customers to wait for the services. In the same way, there is a user who is trying to access the LeoAxis.com website. In the browser, they are searching for LeoAxis.com, right? So what happens here? The browser is asking the DNS recursive resolver first, right, to get the respective IP address details. The resolver, it is asking the DNS authoritative name servers. Finally, from the authoritative name servers, right, we are getting the information. Okay. Now the DNS is replying that information to you. Okay. And the DNS, this recursive resolver, it also caches this data for a temporary period of time as per the TTL time till you. Now this user is trying to reach this server where the LeoAxis website is running using this respective IP address for the internet. And this is what we know so far. Now let's say even these DNS servers, which are helping us, right, which are helping you in order to resolve these IP addresses, it has some limits, right? Even this DNS server has some limits. Let's say it can handle 50,000 DNS queries. Let's say it has the capability or the capacity to handle 50,000 DNS queries per second. It means there are the 50,000 users at a time. If the 50,000 users is asking for LeoAxis.com, the DNS recursive resolver or this complete DNS system is able to respond to the 50,000 users per second, right? Okay, but beyond that, the responses might be slow or drop. Okay, beyond that, it is taking a lot of time to respond back to give this information. But per second, it can handle the 50,000 users who is searching for the LeoAxis.com. Beyond that, the response might be slow. You're getting the very slow details or slow information. So this is where, right, the attackers happens. Let's say there's an attacker. Okay, he does not care about the website or application. He's not the genuine user. He does not care about the services of the application, right? He thinks that if I stop the DNS from replying, okay, this attacker is very clever. What is thinking that from replying, right? If you stop this DNS from replying to everyone, right? It means no one can reach this server. no one can reach the server because the DNS is not helping you to get the proper IP address. So here the attackers is using the botnets. Botnet means it's a thousands of missions. They're using some thousands of missions. And these thousands of missions each send queries continuously to this DNS. Okay, these missions continuously they're sending the queries to this DNS. These thousands of missions are searching for the LeoAxis.com continuously. Okay, right? As I told you, what is the limit of the DNS? 50,000 per second. But these attackers are generating 5 lakh, let's say 5 lakh requests per second. Do you think will the DNS able to respond to the 5 lakh customers per second? No, the DNS is overloaded. We are putting a pressure on the DNS. The DNS is overloaded. As I told you, what happens if it is overloaded? Because it is reaching its limits. If it is crossing more than 50,000, definitely it stop or slow down its responses. Right? So now the DNS server starts overloaded, right? And it starts not responding to the customers. Okay, now it stopped responding to the customers because it is overloaded now, right? It is overloaded. Now, whenever there is a legitimate users, right? You are searching for leoaxis.com. Will the DNS will help you out? No, because already the DNS is overloaded. The DNS, it won't respond to you. You won't get the proper location details. So it is very slow now. So what this application now? So in this process, what will happen? I might lose the customers, legitimate customers. So my business will come down, right? So zero traffic, zero users. So completely my business will come down. So this type of attack is known as DDoS attack, right? So to overcome this DDoS attack, we have the solution in the form of managed DNS, which is known as managed DNS. So in the managed DNS, we are using something called Anycast and massive capacity, a small filtering. Okay, we are using massive capacity. So there are the solutions. Okay, Anycast, massive capacity, smart filtering. So they are the solutions that which we are using to overcome this DDoS attacks in order to save this DNS from the attacks, right? I hope it is clear to everyone so far. Now let's conclude this security best practices with the final type of attack, which is known as zone transfer. So to understand this zone transfer, let me explain you in detail. So here, in this zone transfer, which is also known as DNS oversharing, to make it clear, first let me tell you what do you mean by this DNS zone. Here, the DNS zone, it means it is a full set of DNS records. As you know, in the name servers, we are creating the information in the form of records with respect to our domain name, right? The records might be like, okay, let's say we are talking about the leoaxis.com and we are creating the records using the subdomains like for www.leoaxis.com. And these are respect to address or else api.leoaxis.com or dev.leoaxis.com. So these are all the subdomains. So if any customer, if any client trying to search with respect to these domain names, we are mapping to the respect to locations, like it might be IPv4, right? It might be CNAME, record type. So, right, we are giving all these details in the form of records. Okay. Now, what do you mean by this zone transfer? So here, this zone transfer means it is a DNS replication. The purpose of this zone transfer is DNS replication. You know, replica means it is a copy. So it means now this is our primary name server, right? It is our primary name server, which is holding all the records. and which is available over the internet, right? Which is available over the public. So that's why the recursive resolver can query the respective information to this primary name servers. And it is also known as master name servers. Now, what if this primary name server fails? So don't you think we need a backup? Right? If this primary name server fails, the recursive resolver, it won't get the respective information from the name servers. So that is why we are having the backup. We are creating the backup. So that is a secondary DNS. So it is a primary DNS name servers, and it is a secondary DNS name servers. It is a secondary authoritative name servers, and it is a primary authoritative name servers. Okay. So we are creating this secondary DNS, and we are telling the secondary DNS, kindly pull the information. Okay. Kindly pull the information from the primary authoritative name server. Okay. We are telling, kindly pull this information into this secondary authoritative name server. So it can pull this, it can pull this information in the two ways. One is AXFR, one is IXFR. So here it is a full transfer. AXFR means it is a full transfer of the records information. It is an incremental only. Incremental means only if any info is changing here. If any data is updated, any record is updated, only that information only it is updating here. Right? So we have the AXFR and IXFR method. Now, if it is open to public, so even the attackers, right? Even the attackers can pull the information. Even the attackers can pull the information of our records. So now this attacker can come to know the complete blueprint. Now this attacker can know the complete blueprint of our records information. So now he know which domain name is mapping to which resources. So you know the complete details then. So which is not safe, right? So that is where we need to restrict this AXFR or IXFR process only to allow the restricted servers only, right? We need to allow only the authoritative name servers to pull this information, but not to everyone over the public. So that is what is known as zone transfer. Zone transfer or DNS oversharing. Fine. So we need to restrict this zone transfer with access. We need to give permission only to the authorized secondary DNS name servers. We should not open to public. If it is open to public, right, the attackers might attack this, and even they might request this complete records information. So with that information, the attacker can come to know which is the server and where it is available. He might attack the respective servers. So that is what we need to understand. So I hope it is clear so far, right? With respect to this DNS security concerns and the best practices. If we connect this same topic to the cybersecurity principles, as you know, in the cybersecurity, we have the principle known as CIA, where C stands for confidentiality, I for integrity, A for availability. So we can interlink these three security concerns with this CIA. So for C, here we are using the zone transfer, right? So we should not open this transfer to everyone. Only to the authorized members only can pull this information. That is what the confidentiality. We need to maintain the confidentiality. And if you see the integrity, we have seen this DNS spoofing where DNS is lying to us. So here to overcome this, we are using something called DNS SEC, right? Domain name system security extensions, right? So DNS SEC. So what do you mean by this? It is a signature or a seal, right? On top of the records. So with this DNS SEC, we can ensure that we are overcoming the DNS spoofing. Fine. It is a digital signature which is validates the DNS responses and prevents the tampering. That is what it is maintaining the integrity. Okay. Now, what is the next thing here? For availability, okay. For availability, as I told you, we have something called DDoS attacks. DDoS attacks on the DNS, where it is making the DNS overloaded. with a fake request, right? So to overcome this, what we are using? We are using anycast DNS, rate limiting, DDoS protection, or Route 53 shield, right? We are using these respective measures to make sure our DNS is available to the customers. I hope it is clear to everyone so far. Fine. I'm going to conclude this DNS series with the final topic. In this final topic, now I'll tell you how the questions might come, right? Let's say if you go for any interview, remember, you need to be very good in this 3C formula. What do you mean this 3C formula? If you go for any interview, make sure you are good in the communication skills and you are good in the confidence level and you are good at the conceptual clarity that you are applied for. If you are good in this 3C, then the game will be one side, right? And with respect to the DNS, if you face any questions with respect to the DNS, like behavioral type of questions, okay, behavioral questions. What do you mean by behavioral questions? Let's say example, let me tell you one question here. You need to answer them by using a methodology known as STAR methodology. First, let me give one simple behavioral question. Then we may decode that how to answer that scenario-based questions with this STAR methodology, which is very, very important. Let me give one scenario first. So let's say a users in your respective organization, okay, users from the respective organization, they're complaining to you saying that, Sai, we cannot access your website. We're able to access your website using this domain name, but we able to access your website using the IP address. If you're in the IP address directly, we are able to access. But if you're in the domain name, we are unable to access. Right? So how would you troubleshoot? So this is a complaint that you got from the respective users. Right? So now in this scenario, how are you going to troubleshoot? How are you going to troubleshoot in this scenario? Right? How you behave with respect to this situation? So they'll put you under one situation to you. Okay, they'll put you under one situation and they'll check how you able to overcome that, how you will tackle that. That is what is behavioral or scenario-based questions. So to answer this, you need to follow a strategy, which is known as a STAR. So if you decode this STAR, STAR stands for it is a situation. T stands for task. A stands for action. And R stands for results. Situation, task, action, results. Okay. First, you need to confirm that when the situation happened or where the situation is happened. Okay. Right. So with respect to your question, you need to say that yes. So during my role as a cloud DevOps engineer, okay, we are running a website, but I got this complaint. Right. First, set the context, saying that the situation. Then explain your responsibility. What is your task? Okay, what is your task with respect to that situation? First, set the context and talk about your responsibility with respect to that context. Okay, here first explain the issues, the situation. First, tell the issues. Then after, what is the responsibility? What is your responsibility during that situation? So what is your task? Explain your responsibility. What problem or challenge were you responsible for? Like my task was to ensure the website is running smoothly, right? Then after, you talk about the actions that you have taken, what you did. Okay. Then after, you have to explain what you did. Focus on your actions, skills, decisions. Okay. You need to tell that I confirm that the DNS is public. The DNS name servers is public. It is a public hosted zone and the records are configured properly, right? So you need to tell your decisions or the action that you have taken care during this particular task. And the last one, the result. What is the outcome? that you had achieved with respect to this situation. So mention the results, the numbers, the impact, or the learning with respect to this particular situation, right? So I hope it might be clear to you. Okay. So with respect to this question, right? So you need to answer that. Yes, I faced this during my organizations. I faced this as a cloud engineer. What I done here, I checked my local DNS cache. Okay, I done the right. So as a cloud engineer or a DevOps engineer, it is my responsibility to take care of that particular task into normalization. And what are the actions that I have taken? I check my local DNS cache like ipconfig, and I also use nslookup dig to identify where the resolution fails. I check the DNS server configuration. I verify the DNS server connectivity, right? And I also observe the log files. So with this, I came to know that the fire rules or the firewall rules are blocking the DNS queries. So I ensure that it is not blocking for further. So with this, the DNS is came to normalize and the users can able to access the website properly using the domain name. So this is how you need to put yourself in the situation and you need to tell your responsibility. What is the responsibility in the particular situation? You need to talk about the actions that you had taken and you need to talk about the results that you had achieved. So likewise, whenever you face any interview with this kind of scenario-based questions or behavioral-based questions, okay, they might ask you, Sai, could you please explain a situation where you tackle any issues with respect to your working zone? So you need to first set the context and your responsibilities and the actions you have taken and the results that you had given out, right? So this is what the scenario or behavioral-based questions that you might face with respect to this DNS, right? So I have attached few more questions with respect to this topic. I think overall like 10 to 15 behavioral questions I have attached with respect to this topic, right? So you may check these complete notes in detail in the description in the GitHub link. Okay, I'm going to attach the GitHub link in the description where you can find the complete notes of this DNS series from part 1, part 2 and the part 3, right? I hope it is clear to everyone. Please kindly watch completely these 3 parts of DNS series, right? I wish you understand this topic. Our next series we're going to do on SDLC, Software Development Lifecycle. And in that SDLC, we will decode what is SDLC, what is a waterfall method and agile methodology. And in that agile methodology, we will decode completely and how the DevOps process, right? How the DevOps process is helping this agile methodology. We'll try to understand these things in the next series. Thank you all. I hope it is clear to everyone. We'll see you soon. Thank you all. Take care. Have a great day.